All right, ladies and gentlemen, we're given the function f of x equals 7x squared plus 3. But, rarely has this ever happened. We are told by the original problem to only look at the part of the graph where x is greater than or equal to 0. So in other words, we are to look in quadrants 1 and 4 only, not 2 or 3. So, and you'll understand why in a minute. Alright, if I turn the calculator on and I hit y equals, and I graph, let me try to get some of that glare gone, here we go. If I graph 7x squared, what is it? Plus 3, okay, plus 3. So I hit 7x caret 2 plus 3 and I hit graph. Now, of course, that is a parabola, but what they're telling us to do is only pay attention to the part of the graph here, just in this first quadrant, to ignore quadrant 2. So they're putting on what's called a domain restriction, and here's the reason they're doing that. Okay? This graph is not one-to-one. If you looked at this function, it fails the horizontal line test. But if you restricted your view by telling us to do this, if you restrict your view only to quadrant 1, then we're getting just this branch of the parabola, and it would pass the horizontal line test, making it a one-to-one function. So when it says, is it one-to-one, the original graph would not be, but with this restriction, yes. We have made f a one-to-one function because of the domain restriction. Now, if so, well, it is so, find a formula for its inverse. All right, so let's do that. Y equals 7x squared plus 3. That's our original function. The inverse function, you know how to find that. To find the inverse function, we change domain and range. So y becomes x, and x becomes y. So we have x equals 7y squared plus 3, and we now need to solve this for y to get a formula for f inverse. So I'm going to subtract 3. I'm going to divide by 7. And now what I'm going to do is I'm going to apply the square root property. If y squared equals a quantity, then y is equal to plus or minus the square root of that quantity. Now, understand, because of the domain restriction, right? The y value that I pick, you know that inverse functions are symmetric with respect to this line. So you already know that this is what the inverse function is going to look like. Correct? I mean, if this is f of x, when we draw the line y equals x, we know that the inverse function has to look just like this. It's symmetric about that line. So where is f inverse? Well, f inverse has x and y values that are positive only. So for that reason, we ignore the negative. So far we've come up with this answer. F inverse of x is equal to, ignore the negative, so it would be the square root of x minus 3 over 7. But remember the quotient rule for radicals. This splits apart as the square root of the numerator divided by the square root of the denominator. And there is a rule from previous courses that you are not supposed to leave a radical in the bottom. So we go through, if you'll recall, the process is called rationalizing the denominator. And what I do is I multiply top and bottom both numerator and denominator of this function by the square root of 7. So f inverse of x is equal to, in the numerator, we use the product rule for radicals, so these two go under one roof. And that product, of course, is 7x minus 21. That's all under a radical. And in the denominator, the square root of 7 times the square root of 7 is the square root of 49, but that is just 7. So that, my friends, is my formula for f inverse. And that is its graph. So what we had to do here is we had to throw out the negative answer. This restriction put us in quadrant 1. Therefore, we know where the inverse function is going to lie as well because of its symmetry with respect to the line y equals x. So we throw out the negative possibility. And we're done.